Hello world, this is Chris with Elevations. I'm going to do a walkthrough on some basic Python programming. One of our Elevations group just happened to get a Raspberry Pi for his birthday. That would be Tripp. Happy birthday, Tripp. But we talked about going over some basic Python programming so he can get into writing some code on his Raspberry Pi. Now you can do this on a Raspberry Pi, you can do this on a hosted VM, say running Ubuntu. You can also do this if you're running a Mac and can open up Terminal and run Python programs in there. But there's a lot of stuff that you can do from this terminal. So this terminal, as I told him, has all the power. You can do all kinds of crazy stuff here. You can mess everything up, or you can make all kinds of awesome things happen. So if you just focus on doing the basic things that you are supposed to do, research you're supposed to do, or if you set some backup points. So if you do mess everything up, it's okay. So the first thing I want to do is use Nano. So Nano is a text editor just built into most Ubuntu or Debian-based systems. So Nano allows me to open up a file. So what I want to do is I'm going to make hello.py. So that's a Python file just named hello. And it brings up this interface. So you see at the bottom there's a lot of different stuff as far as what you want to do with this file once you're done. But what I'm going to simply do is do a print. And in order to print actual text, you need to first say print and then set up parentheses. And then you set up these quotation points. So the parentheses is a requirement for the actual print portion or the command. If I have a variable, say variable var, I'm going to print var, but I have to actually establish what var is first. But if I want to print actual text, I can just say hello world, or actually spell it right. There we go. Hello world. That's all we need to do in order to do that. So you can see in that bottom left hand is the X for exit. You push and hold Control and then hit X. Save, modify buffer, yes. Hello.py, that's correct. Alright, so now if I do ls, you'll see some of the other ones we have in here, but that's also hello.py. Now on here, we have Python 3. Now you could, if you have a Raspberry Pi, a lot of times you just hit Python, or if you have Raspberry Pi running Python 3 code, you use Python 3, but on this particular system, I have Python 3 going, so that's what I'm going to do. So hello.py. It says hello world. That's super cool. So you can run that over and over again. Notice I can type it out. See, py python space hello. Yeah, spell everything right. .py. Always remember the .py is a Python file. You can click that. Now, if you hit your up arrow key, that'll actually just replay your previous one, and you can actually hit up arrow key and go through a lot of your previous commands and just retype all those. Now, if I want to, for example, change what I want it to say, so I can, since it's Tripp's birthday this week, I'm going to say happy birthday, Tripp, and then throw some exclamations in there. Same thing. Now I'm just putting something text-wise inside these quotations. Notice we do have quotations. A lot of different ways to do this, but we're just going to do this with Nano for now. Same thing, Control X and then hit Y to save the buffer. Then now if I do Nano, or if I do the Python, where is Python? I'm just going to type it. So if I do Python hello.py, click. Uh-oh, I messed that up. Oh, because I'm running Python 3. Simple fix. There we go. Python 3. Happy birthday, Tripp. So that's what we have. Let's clear this off so we make it a little bit easier to see. So the same thing. Now if I just go back up, open that up, hello.py. Now again, since it is the hello file, I'm going to get rid of happy birthday Tripp, because that was Monday. So it's no longer happy birthday, but still happy birthday. So I'm just going to say hello world, exclamation, Control X, save, Y, buffer, enter, yes, and then Python 3 hello.py, and then should go back to this. Now, if we want to start allowing both input and output, so we're taking input from a user, I'm going to do nano in-out.py. So if you don't have a file already called in-out.py, this is actually going to create one once you save this file. So right here we have a blank screen again. So with this blank screen, we start back over again. So let's just do, I'm going to make a variable here just called printout. So what I do is I do printout equals, and then I type input, and then I'm going to do quotation because I want it to ask a question. Let's say input what you want to print, and then space. I got to close my quotation and close my parenthesis. And then I can do print, and then I'm going to print out what I have saved in the printout variable. So now I have printout. And that's all I actually need on here. So let's go ahead and save, Control X, Y, yes. Now if I do Python 3 inout.py, input what you want to print. Let's say, how about this? Tripp is awesome. So now it's actually going to save this string or these characters into that previously seen variable. So input what you want to print, Tripp is awesome, enter, then it saves that as that variable, and as you can see right here, it actually then prints that right back out. That's cool. So that can be changed to whatever you want it to be. I can also just go over here, the thingy I wanna print. That's it. And then you just create a variable by having whatever you type in here before your equals input. Hopefully that makes easy sense for you here. And then now, as long as I type everything appropriately, the thingy I wanna print. So I might have that right. You can see that right there. But let's go ahead and save my buffer in out. Now I'm going to come back over here. Python in out. What do you want to print? This thingy. And that says this thingy. Yay, that actually worked. All right, so now we have some inputs and outputs. You can do a lot of different stuff with your inputs and outputs once you understand how that works. So next, let's look at doing some mathematical equations just to get some really basic stuff here. So let's do a nano, let's just call it math.p. So here is our blank screen. So let's just say, let's go A equals input. And then I'm going to say, what is the first number? Okay, and then close. And then it's going to give a prompt with that particular phrase. However, if you want to make sure when you type in your first number that there's going to be a space, so you don't actually put the number right on top of that question mark, you have to make sure to put that in these quotations as well. So let's just do A and B. So A equals input, B equals input, let's see, and then we're going to say, what is the second number? Question, close, and then I'm going to print, and then we're going to say A plus B. Now, that's all I need there. Now, I know this is not going to be exactly the way I want it, but I want to make a point here. So now I have A equals input and B equals input. So if I want to run, say, Python math.py, yeah, I got to do Python 3 on my environment. So Python 3 math.py. What's your first number? Let's say 2. And then my next number is 3. So my answer should be 5 if we do 2 plus 3, right? Now it says 23. So what happened there? Is there a crazy magic? No, it's actually, the fun part is it's taking 2 and 3 and literally just putting them together. So let's open this up so you can see what's going on. Open this up with nano math.py. So here, A equals input. So that's literally just making a variable a, and then input is whatever this string is. Now, if I want to actually input the number, that's where things get a little bit more interesting. Here, what we have to do is right before we say input, we need to indicate that it is going to be an integer. So int means integer. Integer is basically just a whole number. So if we do start getting into decimal points, that's where you start, you have to declare it as other types of variables, but we're going to start with integer just to make things easy. So notice here, as I do this, being the int, I have to open and close another parenthesis, because you see this is the section for what's actually going to be printed when I ask the question. And then this section right here is the input. And then out entirely here we have the int. So now print a plus b at the end. Since we do have two integers, it's going to add the two integers together this time. So let's go ahead and hit save. All right, so let's do now, we can do the same program, Python 3 math.py. Now I'm going to do the same numbers, 2, second one 3, now look, we have 5. So that way it's actually adding them as integers, as whole numbers, as actual numbers, and not characters like the number 2 as a character that you would write out. So the cool part is once you actually start doing math stuff, as you set these up, you can set these as floats, you can set these as integers, you can set all kinds of crazy stuff when you're doing your variables. You can also make this into a loop, but we'll get that in maybe say like we'll do another lesson with that. So this is some basic stuff. We're just doing a printout and then doing input, output, and then this is now math. And once you kind of combine all this stuff together, you can get really interesting with it. How about this? Let's do, just for the sake of it, I'm going to do print. I got to open, and then I got to close, and then I got to open and close, and then I'm just going to make a line. Let's actually make a line. So then I'm going to take this whole thing, and then now let's go ahead and do the whole thing over again so we can have it run twice. Okay, so a equals, and then we have print a plus b. So let's go with r equals int, and then I'm going to say input because we have to take more input. I'm going to open again, I'm going to do this, and I'm going to say what is the third number. Then I remember I got to close, and then I got to close. Always remember, everything that you open, you have to close. And it will give you an error if you start making programs where you open things and don't close, or close and don't open, because having the setup, the parentheses set up properly is what's really going to indicate everything for you. So I'm going to do p. So p equals int. I'm going to start doing the same thing. Input, open again. What is the fourth number? Now notice, since I'm going to put that in these quotation marks, even though it's a 4, it's just a character. All right, so now I can do the same thing. I can do print, and then I'm going to say r plus p. Okay. All right, now I'm going to hit Control X, buffer, hit Y, then hit enter to save it. Now let's go ahead and run this. So what's your first number? Let's do the same thing, 2, 3, we should have 5. Now I see my line. Then I see what's the third number. Let's do 5. Uh-oh, what happened here? So look at that, int in out. So that means, as I was typing, I did something bad. Yep. Look at that. Now I want to go back. Actually, let's go back and just kill this and look again exactly what it shows. So the program started running, and then we had a problem. I actually didn't do this on purpose, but it's good that it happened so you can kind of see what happened. So this indicates what file that it happened in. So this is the math.py, line 13. We don't have the line indicators on right now, but you can see that in some of the other stuff that you might be working on in the future. Now, this is the specific line that it's having problems with. Note, it just says exactly what the line is, and then it gives the error on this particular string of characters. So that's where I know that's my problem. And then it says name error. Name in out is not defined. So it actually says, did you mean input? Yeah, that's actually what I meant. So let's go ahead and open that back up again. And it looks like basically I just got one letter wrong. So that's part of programming, is every little detail matters. Now I'm going to go through and hit Control X, hit Y for the save the buffer, save to that file, and let's see if I can run that again. I'm going to do the same thing again. And this is what programming is, guys. So if this doesn't seem fun at all to start off with, there's troubleshooting built in. It's okay if you make mistakes. You just got to learn from it, see what it says, and kind of pivot and go from there. So now I'm going to use 5. Let's see if it gives me another error. It did not. What is the fourth number? 5. And then it says 10. Now the program's over, so it just gave me my results of 5 and 10 and then exited. If you want to do other stuff, you certainly can. Actually, I'm going to get out of that. I want to do nano. Now, let's go ahead and get more fun with this. Let's just say A plus R. So it's going to start printing all of these things. Actually, I can also do that. Let's go that, because I can get my color coding. That makes it more fun. And then right here, I'm going to do another print. And then I'm actually going to just print a blank line instead of having the line, because that is going to give me a little bit of space so I don't have it right underneath that line. And then over here, I'm going to do print. And then let's just say this time I'm going to do B plus P. And then I'm going to say print, open and close. Look at that, open and close. And then open, close, and then this is the end of the program. I could spell it right too. Bye. That's all I want. Okay, and then now Control X, save modify buffer, Y. This time, since we made changes, I'm going to do math2.py. Save under a different name. Yes. Now if I hit ls, which is the list, I can see we have math and math2.py. So here I'm going to do Python 3 math2.py. Alright, what's the first number? Let's kill this all. I'm going to kill everything. And I'm going to clear so it's easier to see all this. Alright, so Python 3 math2.py. What's the first number? I'm going to again go 2. Then I'm going to go 3. Now notice how we have these little breaks here. This is exactly what I wanted, where I don't want the next printout to be directly on that line. So notice we have that little bit of space. What's the third number? I'm going to do 5 again. The fourth number, 5 again. And then it does those calculations that we talked about. So it does give me the third and fourth adding together. And then it does take the first and adds it to the third. So that would be 5 plus 2. That equals 7. Right? And then the next one, since B is our second input, and then R being our fourth input, we have 5 plus 3, 5, 6, 7, 8. Looks like that's right. And then it says, this is the end of the program. Bye! And that's everything it is. So that's all the math stuff. That's some input. That's some output. That's some printing things. You can input purely characters like you saw before. It will just string them all together as opposed to add things if you do have numbers. If you do want to do mathematical things like we just saw here on the code, and I'm going to open that up just so you can see it, you do have to do the int so you can actually treat your variable as an integer as opposed to just a character. And a character could be like a letter, a character could be a pound sign, a character could be an actual number. But if you don't save the variable as an integer or as a float you'll see in the future, then you can start having issues because you cannot add two things together that are characters, it's just gonna put it together. So if it's a plus b, it's literally gonna be like ab, or it's 5 and 5, it's just gonna be 5 5. So if we want to do actual integers and start doing math, you need to save your variables as integers, and that's what these are right here. So a is now my variable, b is my variable, r is my variable, p is my variable, and they are all set up as integers, as we can see here. All right, I think that's a good place to start. I'm going to hit Control X. I didn't make any changes. So that's everything we have. Hopefully you learned something today. And as always, like and subscribe below. Thanks for watching.